Hello, geometry. This is 12.5, permutations and combinations. A couple of fun words, long words. I think it's kind of neat. We'll learn some new keystrokes on our calculator as well today for those who have it. There's also formulas that we can use as well. Permutations and combinations deal with the order of and groupings of what you can do. So like if you have 5 different balls, a football, basketball, baseball, soccer ball, softball, okay? Golf ball, whatever. If you have 5 different ones, combinations would say, okay, how many combinations of 3 different balls could you have? And they'd want to know, okay, you could have a basketball, football, soccer ball. You could have a basketball, football, baseball, okay? But with combinations, the order in which you have them does not matter, okay? So with a combination, you could say a basketball, football, baseball is the same as a football, basketball, baseball. It's the same 3 balls, just in a different order. So combination, that order doesn't matter. Permutation, think of like a perm. If you ever get a perm, it's permanent. Okay, so permutation, the order does matter. So if you're picking teams for a basketball or starters for something like that, hey Tony, if you're starting, if you want to know how many different ways can 5 starters come off the bench, okay, well if you have 5 starters, the order in which you come off the bench would matter if that's important to you, okay. So you're looking at, okay, I only have 5 starters, there's my combination, but what order am I picking them from, okay. So the thing to remember here is when we're dealing with a permutation, the order matters. Okay, the order in which you pick things matter. Combinations, you only need the groups. Order does not matter. The order in which you do things. Okay, so let's look at some of these outcomes here. Look at explorations 1 and 2, and then we'll jump to some more definitions. So we have 2 coins being flipped. So here's 2 coins. Heads and tails, whatever. Another coin is being flipped. Tails and tails. And then a spinner is spun, and our spinner has 3 outcomes. So how many outcomes are possible? And they made a nice tree diagram for us. So the first event is a coin is being flipped, and from that coin you can get a head or you can get a tail. Now you're going to flip another coin, so here's another coin, and from that one you can get head or tail. So if you got heads first, you could get a heads or tails second. If you got tails first, you get a heads or tails second. So right now we're at 4 different combinations. Okay, 4 different combinations. Now here, this event right here is our spinner, and you can get 1, 2, or 3 from each one of these. So you notice we have 1, 2, 3. So if I go heads, heads, and then 1, 2, 3, there's 3 events. Heads, tails, 1, 2, 3, there's 3 events. Tails, heads, 1, 2, 3, there's 3 events. Tails, tails, 1, 2, 3, there's 3 events. So there are 12 possible outcomes. And the easiest way to do that is just take the number of options you have for these. Coin is flipped, you have 2 options, heads or tails. 2 options, heads or tails for the second coin, 3 options here, 2 times 2 times 3. So list the possible outcomes. This can come in handy. And make sure you do it as detailed as possible. So we could have heads, heads 1, heads, heads 2, heads, heads 3. We could go heads, tails 1, heads, tails 2, heads, tails 3. Okay, that takes care of those 6. Go tails, heads 1, tails, heads 2, tails, heads 3, and then tails, tails 1, tails, tails 2, tails, tails 3. So there's our 12 different permutations, because the order would matter here as well. So here, how many events are shown? They just show you the tree. Now remember, back up here, the coin was flipped, and here are the 2 results. Another coin is flipped, here's the 2 results. The spinner spun, here's the 3 results from that. So each set of lines represents an event. So here we have like a coin being flipped. There's 1 event. We have a spinner. We have an X and a Y, and then we have an A and a B. So we have 1, 2, 3, 4 events being shown there. 4 events. What outcomes are possible for each event? Well, you could have A1XA, A1XB, A1YA, A1YB, all of those. Okay, so A and B would be your first outcome. A or B. For your second event, you could have 1, 2, or 3. For your third event, you could have X and Y. So there's 2 of them there, there's 2 of them there, you have 3 of them there. For your 4th event, you can have A or B again. So again, there's 2 of them there. So how many possible outcomes? Let's multiply these. 2 times 3 times 2 times 2. So 6 times 4 is 24. There should be 24 possible numbers down here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 for the first half. 12 times 2 would be 24. List of possible outcomes. We can handle that. I started that earlier. I'm not going to do that all now on video for you. Okay. So, permutation. This is when order is very important. When order is very important. Okay, you're going to do permutation. So an example of that would be if you have different positions for something. Okay, like if you're picking or awards. So if the first person chosen gets a new car, a second person gets a donut. Okay, the order in which you're picked does matter. You want to be first. You want that first position. Okay, now if they're picking 5 people and each person gets a new car and it's all the same, it doesn't matter whether you're picked first or picked 5th. You're getting the same thing, so that order would not be important. Okay, n factorial. This is represented with an exclamation mark. So n factorial. And this is a quick way to show a string of multiplication. A lot of times this is a secondary function on your calculator. So a quick way to show a string of multiplication. So if I would have 5 factorial, if n is 5, that would mean I have to take 5 times 4 times 3 times 2 times 1. Okay? On the calculator, on this one, I'm looking for this sign right here, the x factorial. So I can go 5, and then it's, oops, not that one. 5 factorial, and you get 120. 5 times 4 is 20. 20 times 3 is 60. 60 times 2 is 120. 120 times 1 is that. Okay? So if you had an 8 factorial, you'd take 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. I'm not going to do that one in my head. 4,320. Okay. So let's look at permutation a little bit, and then we'll go back up and look at combinations. Write that down. Okay, so the number of permutations of n objects given by this. Now, nPn is n factorial. Now, what happens here is this first value. I don't like they're using the same one. The first one is the total number of choices that you have. The total number of choices. The second n is how many choices you will use. In this case, you're using all of them. Okay? So n permutated n times would equal n factorial. Okay? So let's say here we have the example, the number of permutations of 4 objects is 4 permutated 4 times. So how many different ways can you read 4 books? That could be a question for this. How many different ways can you read 4 books? Okay. Well, once you read a book, you're done with it. So the order in which you're reading these books does matter. So you're going to read a certain book first, a certain book second, third, and fourth. So that would be 4 permutated 4 times, and that's 4 factorial. And again, I like to think of these as how many choices do you have. So for your first book, you have 4 choices. Now for your second book, you have 1 less choice, you have 3 choices. For your third book, now you only have 2 choices, you only have 1 choice for your first book. Okay, that's a fundamental counting principle. Okay, you just multiply how many choices you have, and that's how many total outcomes you can have. So 4 factorial is just, okay, my first book I have 4, my second book I've already read 1, so now I have 3. My third book I've read 2, and now I have 2 left, and then my first book. Okay, so you'd have 24 different ways that you can read those 4 books. Now let's say you have n objects taken r at a time. So this is when r is less than or equal to n. Okay, so here's your formula right here. So n objects taken r amounts of time. So again, this n is the total number of objects. The r is how many you are selecting. So let's say we have 7 books, and this is our formula here, n factorial over n minus r factorial. Let's say we have 7 books. How many ways can we read 3 of them? How many ways can we read 3 of them? So again, the first book we read is an option. Okay, the second book is a different option. And third book is a different option. We're not going to read all 7 though now. Not like our first example. We're going to read only 3 of them. So how many different permutations of 3 can we have here? Okay, so this would be 7 permutated 3 times. So our formula, this is n equals 7, r equals 3. R equals 3. 7 permutated 3 times. So this would be 7 factorial over 7 minus 3 factorial. Okay, 7 factorial over 7 minus 3 factorial. So that's 7 factorial over 4 factorial. Okay, we can calculate this, but watch what happens here. We have 7 times 6 times 5 times 4, and then that keeps going on. Now I stopped at 4 because that's the number that's on bottom. And these actually can cancel off, leaving us with 7 times 6 times 5, 42 times 5, that's 210, I believe. Check my math, yep. So there's 210 different ways you can read 3 of those books. Now again, think back with permutations, think back to how many options you have for each event. So the event of reading a book, at the first book you read, you have 7 options. The second book you read, you've already read one, so now you have 6 options. The third book you read, now you have 1 less, and now you only have 5 options. You're only reading 3 books, so if you just take 7 times 6 times 5, do 3 numbers down, you get that 210. You wouldn't have to mess with this formula quite as much. Okay, so a combination. Combination, let's go back up here. When order is not important. Okay, let's say we're rolling a die twice and we want a sum of 7. Okay, does the matter in which you roll the numbers matter? Okay, if you roll a 1 and then a 6, or if you roll a 6 and then a 1, does that matter whether the 1 comes first or the 6 comes first? No. What's really important is we want a sum of 7. Okay, whether you do a 3 and a 4 or a 4 and a 3, that doesn't matter. Okay, it's still going to be 7 no matter what order you do it. So the order does not matter there. So this definition gets a little bit longer, and our formula gets a little bit longer. It's the number of combinations of n objects taken r at a time. So again, the n is the total number of objects taken r at a time. How many we're choosing. How many we're choosing. So it's n factorial over n minus r factorial. That's the same as the permutations times r factorial. This is new. So this is new from the last formula we had. So let's say we have how many combinations of 5 starters can you select from 12 players? Now, we're not looking for the order of these starters. We're not doing like a starting lineup. This one's listed first. We're just saying how many combinations of 5 can we have. Okay, so if you have 1, 2, 3, 4, and 5 players, that would be the same as 5, 3, 2, 4, 1. Choose them in that order. So the order does not matter here. So we want 12. We have 12 players, and we're choosing 5. So N is going to be 12. R is going to be 5. Now, 12 choose 5. So we're using this formula up here. N factorial, 12 factorial over 12 minus 5 factorial times 5 factorial. So this would be 12 factorial over 7 factorial times 5 factorial. Okay, there's some ways to clean that up. Let's just go straight to this. So 12, hopefully you can see that. There we go. 12 factorial divided by, I'm going to use a parenthesis here, 7 factorial times 5 factorial. And we get 792. So there's 792 combinations. So next time you're on a team, you can see, okay, how many, say basketball, whatever, it's volleyball, you do 6, football, you do 8. How many different combinations of 8 or 6 or 5 can I get out of this? Now, a lot of your calculators may have this on there. I want you to look at this one. You look above the multiplication division sign, you see the NPR and the NCR. Those are the operations, and these formulas are programmed into there. So I can do the same thing. I'm choosing here. I want 12, and then I want to choose 5. So it goes 12, choose 5, and we get 792. Does it for us. Okay, the other one we had, which was here, 7 books. How many ways can you read 3 of them? That's 7 permutated 3 times. So 7 permutated 3 times, we get 210. This is what we have there. Okay, so here, exercise 1 and 2, find the number of ways you can arrange A, all of the numbers, and 3 of the numbers in the given amount. So notice we're arranging these. So the order is important. So we're using permutation or combination. We'll be using permutations. So for A, we're arranging all these numbers. Now there's 7 numbers. There's 7 numbers here. So for A, we had to have 7 permutated 7 times. That is just 7 factorial. So 7 factorial is 5,040. So if you're just taking 2, 5, 6, 4, 7, 8, and 3, there are 5,040 ways you can arrange those 7 numbers. Now we're just going to arrange 3 of them. So that's 7 permutated 3 times. So that'd be 7 factorial over 7 minus 3 factorial. So that's 7 factorial over 4 factorial. So that's 7 times 6 times 5. Again, we only have 3 numbers we want. We have 7 options for the first one, 6 options for the second one, 5 options for the third one. We can also do 7 permutated 3 times, and we get 210, which we know that's 210 from earlier. Okay, so number 2, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 numbers here. So for A, we have 10 permutated 10 times. That is 10 factorial. Big number. That is 3,628,000. 2 8s. There we go. 3,628,800. Different ways to put those 10 numbers. So B, 10 permutated 3 times. That would just be 10 times 9 times 8. So 900 times 8, 7,200? 720. 720. Yeah, 90 times 8. So notice the permutations, only taking 3 of them, they drop significantly. Okay. Your rock band has 9 songs recorded, but you only want to put 5 of them on your demo CD to hand out to local radio stations. How many possible ways could the 5 songs be ordered on your demo CD? Be ordered. There's our key word. At first I thought this would be a combinations. You just need 5 of them on there. Doesn't matter the order in which you have them, but you want 5 of them. Okay, so we only want 5, so that's our R value. we have 9, there's our n value. So we have 9 songs, and we want to permutate 5 of them. So that'd be 9 factorial over 9 minus 5 factorial. So that's 9 factorial over 4 factorial. So let's go from 9 down to, don't include 4. So 9 times 8 times 7 times 6 times 5. 5 different songs that you're choosing. Or we can just go 9, permutated 5 times. And there are 15,120 different ways you can order those 5 songs out of the 9. A witness at the scene of a hit-and-run accident saw that the car that caused the accident had a license plate with only the letters I, R, L, T, O, and A, so 6 of them. Find the probability that the license plate starts with T and ends with R. So find the probability that the license plate starts with T and ends with R. So there's the T, there's the R. Notice we have 4 other different options. Okay? So of these 6 places, 4, 5, 6, we want to start with T and ends with R. We want the probability of that. So what we need the number of these. Now, the order in which you put these would matter. So the number of these permutations divided by the total number of permutations. Okay, so the number of these permutations, notice we have 6 spots, but we only have to choose 4 of them. Okay, so what we're needing here is we need to have 6, and we need to permutate 4 of those. Now, all together here, we have 6, and we're going to permutate 6 of them. So we're going to end up with this over this. So the total number of permutations would be 6 factorial. 6 times 5 times 4 times 3 times 2 times 1. And that's going to be 720. The number of these permutations, again, just ask yourself, okay, this one's fixed. I have 4 combinations for this, 4 options. I have 3 options. I have 2 options. I have 1 option. So 4 times 3 times 2 times 1. That's what this is going to... Back up. Hang on a second. You only have 4 options here, sorry. That's 4, choose 4. 4 permutate 4 times. That's what dawned on me there. Okay, so that should be a 4. You only have 4 options. You have the I, L, O, and A. These 2 are already fixed. So you're going to have 4 factorial over 6 factorial. 4 is 4 times 3 times 2. 4 times 3, 12, 24. So 24 over 720. 24 divided by 720, that is 1 out of 30. Which is 0.33 repeating, so about 3.3% chance that the first one starts with T and the last one starts with R. We'll look at a couple more examples there. How many possible combinations of 3 colors can be chosen from 7 colors of the rainbow? Okay, possible, there's your keyword combination. So you have 7 colors of the rainbow and you're choosing 3. Okay, so you need 7 factorial over 7 minus 3 factorial times 3 factorial. That's 7 factorial over 4 factorial times 3 factorial. 7 factorial, we know, is that the, where's that at? No, 5,040. 4 factorial was 24 times 6. So 5,040 divided by 24 times 6, that'd be 144. And you get 35. So we have 35 combinations. Okay. Again, we can do 7, and we want to choose 3 of them. And you get 35 that way as well. Okay. So a couple more from the textbook that I want to just look at real quick. Finding those probabilities. Okay, so finding a probability using permutations. You have a town parade. You are right on a float with your soccer team. There are 12 floats in the parade, and their order is chosen at random. Find the probability that your float is first and the float with the school chorus is second. So step 1, they wrote down the number of possible outcomes. So they could have 12 factorial number of orders, 12 factorial. Step 2, they write the number of favorable outcomes. So those are the terminologies they're using. What are the possible outcomes? This is the total that we talked about. Favorable outcomes, this is what you want. Okay? So if the first two things are set, that means there's 10 different ways that the remaining 10 floats could be ordered. So that's 10 factorial. So the probability would be 10 factorial over 12 factorial, which was 1 over 132. So if they go off this question here, suppose there are 14 floats in the parade, find the probability that the soccer team is first and the chorus is second. Okay, so the favorable outcomes would be, well, your first two are taken care of, so there's going to be 12 factorial. Your total outcomes would be 14 factorial. So it would be 12 factorial over 14 factorial. You'd figure that one out. Okay, here's another look at combinations. Notice BD and DB are the same pair. In a combination, they're the same pair. It doesn't matter which order they're in. In a permutation, they would be different. Okay, so probability with a combination. So your book has selected 14 photos, including one of you and one of your friends to use in a collage for the yearbook. The photos are placed at random. There is room for 2 photos at the top of the page. What is the probability that your photo and your friend's photo are the 2 placed at the top of the page? So up there at the top, it doesn't matter which one it is first. It just says we want you 2 up there. So the order in which those first 2 are doesn't matter. It's not like that parade where you have a first and a second one. You just have the 2 up top. So we have to use combinations with this. So again, you're going to find out the total number of possible outcomes as a number of combinations of 14 photos taken 2 at a time. So how many ways can we choose 2 photos? And it doesn't matter the order in which you choose them. So they did 14 choose 2, and they got 91. Find the number of favorable outcomes. Only one of the possible combinations includes your photo and your friend's photo. So they just said, okay, of those 91 combinations, only one is the one that we want. So we're going to take 1 over 91. Because it doesn't matter whether you're first or your friend then you. So their example, suppose there are 20 photos in the collage. Find the probability that your photo and your friend's photo are the 2 placed at the top. We just take 1 over 20 choose 2. Okay, so that example there's one combination that you want. So there's 1 we want, and there's 20 choose 2 possible. Okay, I'm calculating that real quick. 20 choose 2, that's 190. 1 out of 190. Okay, so notice the probability goes down the more photos you have. So that's it for now. There might be other questions, but feel free to ask as those come along, and we'll see you soon.